Good morning, friends. Today we're going to talk about the fundamental 8 types of reactions in chemistry. Before we dive into the types of reactions, I want to take a moment to talk about state symbols, a critical part of reading a written reaction. So chemists use state symbols to define molecules in a reaction by their state of matter. S is solid, L is liquid, G is gas, and then probably a new one for you, AQ is aqueous. We'll talk about that in a second. And you can see in this sample equation 2 moles of solid sodium react with 2 moles of liquid water to form 2 moles of aqueous sodium hydroxide and 1 mole of hydrogen gas. Now, you will notice that these state symbols only show up as subscripts at the very bottom of the reaction. We don't write them big. They're very small, and don't throw them in big capital letters. Just like that, simple. We won't use them often, but when they're there, you do need to pay attention to them. Now, what is an aqueous solution? Aqueous solutions are molecules that are dissolved in water. Even though the water itself might not be part of the reaction, if it doesn't participate, it won't be written in. So anytime you see an aqueous solution, just know it's dissolved in water. Now, let's get on to the chemical reactions. There are 2 main categories of chemical reactions. The first category is double replacement reactions, and the second category is redox reactions, which stands for reduction and oxidation. In our double replacements, the ions of two compounds will swap places to form 2 new compounds. So the ions, they get exchanged and the elements shuffle around. There are 2 types of double replacement reactions. The first one is a precipitation reaction, and the second one is an acid-base reaction. Precipitation reactions are best identified by the presence of a solid product paired with an aqueous product. And in these, we're going to have 2 liquids that are going to combine to form a solid. The next kind of reaction, acid-base reactions, are just as easy to recognize as their reactants. The reactants are acids, which start with a hydrogen, and bases, which start with a hydroxide, or rather end with a hydroxide, or an oxygen and a hydrogen, an OH group. And the products at the end of an acid-base reaction will always be an ionic salt and water. So you'll always end up with water at the end and an ionic compound, and your reactants will be an acid that starts with a hydrogen and a base that ends with an OH. It doesn't matter what the elements are. If you have your hydrogen and you have your OH and you have water at the end, it's probably an acid-base reaction. Now, on to redox reactions. Redox reactions are reactions that involve a loss or gain of electrons. A common memory tool to remember which elements are oxidizing or reducing is Leo-Ger, where oxidization is a loss of electrons. We use Leo for that one, lose electron, oxidize. And reduction is the gain of electrons. We use Ger for that at the end, gain, electron, reduced. It does feel a little backwards. That's just what they're called. You're not really going to need to know how to recognize redox reactions. Well, you'll need to know how to recognize the redox reaction, but you won't need to recognize which element is reduced or oxidized. To make it really simple for you, if you want the lazy way of identifying a redox reaction, just look at the products, look at the reactants, and determine that it is not a precipitate. It's not a precipitation, so there's no aqueous, or there's no solid getting made, and prove that it's not an acid and base. And if it's not one of those 2, it's a redox reaction. There are a few types of redox reactions that you must know. These are synthesis, decomposition, single replacement, and combustion. In synthesis, two or more substances combine to form a more complex substance. A good example of this just being the format A plus B equals AB. Now, decomposition is the opposite of synthesis. Here, we start with one substance and we break it down into two simpler substances. AB combines, or not, rather not combines, AB yields A plus B. It gets broken apart. And these reactions will only have one reactant. In single reactions, one substance is replaced in its compound by another substance. So A plus BC will react to form AC plus B. You notice the A and the B, they swap places in there. And you'll notice that in these, it's typical that an anion will swap with another anion. So you might have two nonmetals or two metals swapping. Or it'll be a cation swapping with a cation, where you'll have two... flip that, sorry. Anions are nonmetals, cations are metals. My bad. So you may have two metals swapping or two nonmetals swapping. And the final reaction to go over is combustion. And combustion includes a hydrocarbon, which is a carbon plus a hydrogen, and it will always combine with oxygen. So you'll have carbon, hydrogen, and oxygen on your product side, or sorry, on your reaction side. And it'll produce, at the end of the reaction, carbon dioxide and water. If your products are carbon dioxide and water, it's probably a combustion reaction. Now, these reactions can be very tricky to learn initially. The importance is to practice them. Always look at a reaction and try to figure out what kind of reaction it is. And most importantly, look for the patterns. Every single one of these reactions has a pattern that it follows. And if you can get used to seeing those patterns, you'll be able to recognize them much quicker. I'm not ever going to give you a bunch of like elements like, oh, here's 5 elements, figure out what kind of reaction it is. We're not going to do something like that. But I can, at any point in time, and you can expect it on your test, I can give you a sample of a reaction and ask you, what type of reaction is this? So that's what you can expect to have to answer. I hope this video is helpful to you. Let me know if you have any questions. Have a good day.
Say hello. Do you know? Tell them to like and subscribe. Nope. Okay.